So yeah, I hope you guys enjoyed tonight's talk, and here's Antonio.
I don't know if we started the stream. Gotta make sure on that one first. Okay, first freaks out. Okay.
Yeah, it's streaming.
Okay, sounds good.
Great.
All right. Well, you might want to kill the picture-in-picture since we didn't hook up the GoPro this time. Didn't have time. Yeah, might as well. Usually we stream with a picture of the presenter, but just didn't have time to hook up the GoPro this time for no good reason. Anyways, I guess I'll just get started. Thanks everybody for coming. This is a talk I've been wanting to do for a while, but I haven't because it really wasn't ready. Back in January, Bao and I did a talk on HTML5 and JavaScript, how much mobile hardware was accessible via the browser. Because it had been a long time since I had checked in with that. I'm sure everyone's the same, you know, you get all these promises, oh, JavaScript's going to do this or that, and then, oh, compatibility isn't there for a lot of browsers. And that was kind of the case with this one, too. The big component here that's been missing is WebRPC, RTC. And I'll cover that here in a second. But now with, I think it was last month, iOS 11, the iOS stopped blocking WebRTC, and that's the camera to stream to the browser. So now I can do it. Originally I wanted to do it, outside and have all my slides be like just off in reality, kind of augmented, but it's a little cold out there and dark, so I didn't feel like doing it outside. And in here's fine. So because of that, I didn't do one of the geocoded examples I wanted because there's just not that much space in here but out like in Kesey Square, that would have been cool just to have a bunch of like people wandering around with their phones and people, you know, thinking you're weird. Okay, so augmented reality. This is what this is superimposing some sort of image usually on top of the real world to give one composite view of both of them. Normal reality is the base, so something in the real world, whether it's visual, location, whatever. I suppose in that regard, it could even be sound, honestly, if you were so inclined. So normal reality is the base here. It'll always be the base for everything I'm talking about here. This is not virtual reality. I'm not going to be talking about virtual reality at all. I'm not going to compare the two. I think they're not apples and oranges, but they're different enough. And virtual reality requires a whole lot more world building rather than overlaying on top of the existing world. So in that regard, I feel like it's really different. So a long time ago, we started talking about AR. And this is kind of the impression I think everybody got. AR was going to revolutionize this or that, whatever industry. In this case, this was a medical ad I saw. And you see the woman here, a surgeon, I assume, cardiologist probably, getting all this real-time data, you know, heartbeat. There's a problem here, and it looks like the main valve there. So the patient has this. I wonder what the other doctor there is looking at, because if this is AR, then only the person with the Google Glass here should be able to see it, but whatever. That's fine. She seems to be reading it too somehow. But this is kind of where we thought, you know, it's going to superimpose tons of data in a almost like life HUD kind of deal. And then that was the dream. That was what we wanted to do. And this is what we did. We did Pokemon Go. We rebranded a game that already existed. What was it called? Ingress. It was called Ingress. And 750 million downloads later, this is a lot of people's experience with AR. I know people were playing here earlier. Yep, looking at you over there. We also did this. Next level selfies. This is a lot of people's also experience with AR. And both of these are kind of not something that tout themselves as AR. They're more fun. You know, they're game, or they're a way to change your face for whatever reason and share. And then it's fine. They are what they are. We also have some practical applications that I find more interesting. This is just the rear view camera. You get this grid laid out so you don't hit stuff, right? It's pretty simple, but how many accidents did it save? There's no way to know. I'd rather have those lines, and especially the one that indicates when I'm going to turn, which way I'm going to go, because I know that's a problem for some drivers that I've definitely seen, where they turn the wheel and think it's going to go one direction and it doesn't. So even just having that little bit of curve there helps you avoid accidents. And it is augmented reality. It's reality based on, or it's augmenting based on what you're doing in reality. You're turning the wheel so those yellow bars move. Here's another practical example. It's going on right now if anybody's watching the World Series. There's a pitch. I know where it went. I can now more easily judge if it's a strike and not just yell at my TV randomly. A lot of times they'll do other things too, where they'll put in miles per hour. Now I know which pitch is coming, or which pitch has already been delivered, how fast was it, and then you can overlay them on top of each other. I can get a scatter of what the pitcher's trying to do to the batter. And if you follow baseball, that is super interesting. If not, it's kind of, who cares? It's also very interesting, not that I have it in this slide, but MLB, just kind of on a side note, MLB actually tracks all this stuff pretty much real time on Amazon. So every pitch, calculations go off to the Amazon cloud and come back for this stuff. So they can overlay stats instantly, like this pitcher's record against this team that are left-handed batters. It all just comes back like that, pitch by pitch, and the stats will update themselves. It's super big data. That's a big data talk, but it's pretty cool. So this is a practical application I saw that I came across that people I know that have used it love it. IKEA app. You can overlay a couch. What does this couch look like in my house? I don't have to take a picture and hold it up. I can actually see it. I can walk around it. I can see the dimensions it's going to take up. This is pretty practical. It's fun too, because you can change the colors and stuff, but we're moving further away from the game aspect of it. Instead, we're talking about how do we get something practical happening in real life that somebody can use. And this is the last examples I really do like. The IKEA one's pretty slick. It also does a sphere of your entire room, so you can put multiple objects and rotate them and all sorts of fun stuff. But this is all mostly mobile app development, native mobile app development. So you see the icon here for ARKit and ARCore. These are the SDKs from iOS and Android. So this is where they want you to start building your AR experiences for your mobile applications that go into Google Play and the iOS App Store. And because this is what they're giving us, I think this is what we're using. I think these are great tools, and I've downloaded them, and they're great, they're cool. But that's what they're pushing developers to use, is these. And I think the reason is much more so the store factor than it is that it's necessary to do it on the native side. The other aspect here is hardware, other kinds of hardware. So like this is from Microsoft, and this is a whole nother proprietary piece of hardware with its own SDK and its own thing to develop on. So now I've got 3 SDKs here for 3 different kinds of applications that my consumers may or may not want. At least 2, right? I'm probably always going to do iOS and Android, maybe not at the same time, but I'm probably going to do that. So, but what about browsers? Everybody already has browsers on your phone. Everybody's got a phone. I'd be surprised if somebody was here who didn't have a phone. And you're going to have a browser on there. Everybody has desktops, laptops. You're all Webdevs. I know you have them. So you also have browsers, on your laptops and desktop machines. So we're already developing for those. So why can't I just use what I have and what I already know everybody else has? Most of the time, I'm targeting one of these anyway. For Webdevs, we're making web pages, we're making websites, web applications, and we're factoring in mobile factors. We have to keep up with that kind of browser too, because Chrome does a better job, I think, of being the same. But some things, including some of the things I'm going to talk about today, those are just blocked by the OS. So that's not a browser limitation. It never really was. It was an OS limitation, and I'm talking specifically about iOS. And we run into these every once in a while where works in my Chrome, why doesn't it work in your Chrome? Oh, I'm on a Mac, you're on a PC. There's still those slight little differences. So this is I guess it's a pain point, a headache everybody deals with anyway. So I don't really want to bring in more hardware than what I'm already dealing with. So we can now with WebRTC. Both OSs on mobile, Android and iOS, have now pushed this through as part of their stuff. They're not blocking it. iOS was. Android's had it for, I think, since, I want to say Lollipop. I think I have it on a slide here. So for a long time, Firefox and Chrome both have been supporting this for a long time on PC. So is Opera, because Opera is basically Chrome. The only one that's still kind of considered a major browser, I think, that's not supporting it is Opera Mini, and that probably never will because it's Opera Mini, which used to be really cool, but things get old. So WebRTC is web real-time communication. So whatever you're streaming from the hardware back to the browser. This covers video and audio. So without this, you can't have a web page that looks through the camera and puts it up on the screen for you. So that, ergo, no AR. So it's the standard has been adopted, like I said. Some of them are different kinds of applications, not necessarily just normal web pages like Skype, which Facebook uses, Google Hangouts as well. You have to allow for a different plugin or a different whatever you need in order to use those applications in the browser. And that's annoying. I don't want to have to ask users to download more or anything else. Permissions is one thing, but asking for downloads and installs is quite a different story, I think. Once that you have deployed them, you're dependent on them pretty heavily, and usually those plugins like that I don't crack open. I don't know if you guys do. So that makes troubleshooting kind of annoying. Not as seamless as it could be if it's just the tools I use every day when I'm making web page A or web page B or web applications. So this is kind of small, and one of my least favorite things about code. So I didn't put a whole lot on here. So how to access it, right? It's just navigator.mediadevices.getUserMedia, and then whatever constraints you have if you want to say only video or only audio, for example. You don't want every single kind of media to stream to the browser. You want just a specific kind. So if this was like a SoundCloud clone or something like that, you might say only audio, and then handle accordingly. And then, of course, catch your errors and say, hey, you can't do it in this browser, and here's why. Conversely, video, or in the case of like a Skype kind of two-way conferencing application in the browser, you would want both. And that's it. That's really it to get it going. In this example, you probably can't see it, but I say video's true. And that's all I really need to get the real world as my background, because that's really all it is when you access the camera real time. The real world becomes your background, and you figure out how you want to add to reality. So not a whole lot of JS to get started. If you do that, you'll get something like this, where we've probably all seen asking for permissions. It's usually notifications, right? Or after that, maybe location, if you're doing a search or something like that. But this is no different. It will ask you for permission. Not every time, but you have to say yes once. And that's a security thing. Native applications only ask you for permission once, and that's usually in the download. You have to agree to all these things, and there's all sorts of rules in each store about declaring what you're asking for specifically. Again, for the very same reasons. But yeah, that's pretty much the only permission you need to get going, unless you want to do geolocation, in which case that's a second permission ask. So why haven't we used it already? And really, it's iPhone. iOS, like I said, just updated last month. And without iOS support, the coverage was, not there. I had an iPhone. I just got an iPhone, like my first one I ever had, last month, and it didn't work. And I was like, oh, bum, I can't do my talk. iOS 11 comes out. It starts to work in Safari. Great, now I can do my talk. But before that, it was the iOS, and it's interesting that the operating system would block it. You can download Chrome for iOS, and it was still blocked. It just wouldn't render. It wouldn't say much unless there was an exception that was being handled by whoever's code, but it just wouldn't work. It would just be black screen. And because of the implementation, I think there's one or two of the libraries I mentioned that's cleaning that up for iOS specifically. So the thing to use for these is just like, if it's JavaScript, the answer is almost always frameworks, right? When is it not a framework or a package or something like that? They all have pretty normal names: AR, JS, for augmented stuff, Argon, all the fun plays on words that packages and stuff get in JavaScript. It's not as bad as like Ruby with all the fun names, but they still like to have fun when you get to name your framework. So these are all just frameworks you can call in. Most of them have a CDN, so you can just play with them right now. You don't have to download them and install them into your NPM or whatever, or get them going that way. So all of these have a GitHub repo. You can go through all the code, and it's all just JavaScript. There are requirements for all of these. JavaScript enabled, obviously. HTTPS for that permissions, that is an HTML5 standard, not really a way around that. Again, iOS 11, because anything just before that just simply isn't going to work, regardless of what browser is actually on the device. It's the OS. And yeah, Lollipop, that was the one I found. That some might work before Lollipop, and that's depending on how much support the OS gives the browser. So it could go even further back. And most of the Androids I've tested that are pretty old, they work just fine. Not a problem with frame rate or anything that I thought I was going to see. Everything was running pretty well. If you want to know more about where it is supported and where it's not, you can go to caniuse.com for the WebRTC. You'll see here that Safari just started. IE doesn't look like it's going to have much support, but now that everybody's on Edge, or Edge is, if that's not really IE, I think it is. Chrome for Android, Android browser. Pretty much, it's getting pretty much across the board. Again, Opera Mini is the one that's probably never going to support it. So this means our support now with iOS 11 is pretty much covered. So like I said, that's why I didn't want to do the talk before, because there just was that big hole of devices out there that this just wasn't going to work on. So like I said, reality is the base of this whole thing. So we need to start with reality. This is how I envision reality. It's just a bunch of dinosaurs hanging out. At least that's what I think. So we can start there with the camera, and that's fine. But we're going to have to choose how to augment it. Has anybody done any AR stuff in the browser? Nobody? Okay, cool. So the first reality type, I think, that most people intuitively are going to want to start with is geolocation, because we can all relate. If you're at some place, you're literally there, right? It's a real thing that I can count on. And the phone can reliably give me that, within, sometimes it's off. It's not perfect. It's not as good as the native application usually. The browser still sometimes puts you a couple blocks off or something like that, but it's getting better. The newer standards are going to get it down even closer, and it's tightening up. And that's simple, again, simple JavaScript, navigator.geolocation.getCurrentPosition. And then it just spits out your coordinates. In this case, I'm spitting out the latitude. From there, I can go on to do whatever math I want to do on it. You can do things like a geofence. So just with some math based on my coordinates, I can say, here's a polygon. Am I in the polygon or not? And that's nothing any further than math. And JavaScript's just fine at that math. We use it here at IDX. We do real estate data, and we do polygon links all the time. So we have to determine whether properties are inside a polygon or not. So based on the edge coordinates and the center, we have a math function that just does that. So, that's an easy one to get started if you need something to tell you whether or not an augmentation is needed or not. A geofence or a specific point. So it could be at the corner here at Willamette, which was one of the ones I was planning on doing, Willamette and Broadway. There would be an overlay just hanging there at whatever orientation I also want, which is also just JS. The next reality type is a physical marker. You can have a symbol somewhere, and when the JavaScript library recognizes said physical marker, it will throw out an overlay on top of it. Like this children's game. This is, I think it's a educational learning letters game. So the V card there has a vulture, the P card has a penguin, kangaroo, and so on and so forth, and the donkeys. So all of this is just whatever cards. And I've seen some applications like this for games, card fighting games. So that way you can have whatever creature or whatever on top of it, and it makes it a little more interactive. I haven't seen really fight each other. That'd be kind of cool. I've seen some implementation of that with hardware, but not with just an overlay. But this is another way to decide when to augment reality. You have this physical, real thing, and then you get an overlay. And this is the other reality type. This is my ugly mug. Just a streaming camera. This would be mimicking what you're going to see. So you see people with the headsets and stuff like that, trying to mimic what your normal field of view is. So I got some practical examples, and I hope they all work. If everybody has their phones, you can get them out now if you want. At least for the first one, I think I got that dialed in. So the whole idea is to display more info than reality has. reality only has physical things we make. But augmented reality has the potential to have whatever we want and easily update. We print out things that are physical, that's fine and good, but they're good that one time if they're consumed, or they're good as long as they hold up before they wear out, which all physical things do. They're also costly to update. So here's a use case, IDing something. We have signs telling us about things, right? Labels out there. There's that apartment complex down there on Willamette. It has a giant label across it. It's like whatever it says. IDX has their signs. Everybody has signs and stuff. And this is a little sign. This is an example of signs we all carry, right? IDs. Lilu's multipass here. This is a card she carries with her image on it. And this is how, in the movie, when she's trying to get into the airport, this is how they identify who she is. They put that card, which is some sort of electronic reader card, into a proprietary machine that goes back to the centralized database. And now the secondary piece of ID, the second factor in her identification, shows up on the attendant screen. This picture matches this picture, that is you. And that's all fine and good for the future, where that's a thing ubiquitously. But the problem we have right now is physical fakes. So we don't have these big cartridges that we can put into this proprietary system that goes back to a central database that are just everywhere. We have these little pieces of card and everybody takes our word for it. This is a website, CHFake, it's called. And they just go off about how great they are at faking IDs. Great. They tout on there about how it's passes the blacklight test. I mean, you've all seen that going into like a club or something. Then there's a barcode on, or a magnetic strip on like California IDs, I believe. Passes that test. Oregon has a barcode. It passes that test for whatever reason. And I'm not even sure what that test does, to be honest. But physical fake IDs apparently do work enough that somebody is selling them. And I think that's a problem. The DMV, they do have this, centralized database of the truth. They do. Level Up doesn't. The Barn Light doesn't. They don't have that thing they can plug a cartridge into. And that's also true for anybody else who you want to identify. Let's say you're at an event and you have security. Anybody can buy a t-shirt that says security. And if you're a big guy, it's way more believable. That's really all you need, and you could probably walk up to anybody and be like, hey, bud, you need to get out of here, and they'll probably get out of your way. So if you're a big guy, get a security t-shirt, and just don't let the rest of security find you, I guess. So the solution may be some sort of AR marker. So you guys here in the front can probably do it. Everybody else, if you want to visit this URL on your phone, if you can read the QR code, if you want to get up and get closer, that's fine too. In the Google link, don't forget to not include the extra G, which I always do. I always put Goog instead of goo. You might, if you're unable to read the hero marker, there are 4 more hero markers on this pillar in the center. And where is my? I had an example here of. Where did I put my? You did?
What are you looking for?
My stickers.
Oh.
Oh, you moved them. Good. So Bal's moving my props in the middle of my talk. We're not streaming, so I don't worry about the camera right now.
We are streaming.
Oh, but we're not streaming my picture, right? So I'm who I say I am because I have this badge on, and this badge has my picture on it. So is the AR thing working for everybody? So you can see, so it's working for him. You can see that this badge matches that badge. I can put this badge on anybody else, and without some sort of other secondary marker, how are you going to know that I'm really who I am? The image for this marker, for the AR layer, lives on the website I choose. So in order for me to forge this little ID thingy, I have to, well, cut out this picture here, right, and replace it with a new picture if I'm Bao Kim. But I also have to hack that website and change that asset. I can't just do this portion of it. And currently, I mean, that's a big way that we use identification is, do you have something laminated? And that's good enough. I just don't think that's good enough. So yeah, that'll work. It's fine. And you'll see my badge there. Anybody, and did it not work for anybody, out of curiosity?
I have an iPhone SE, so.
Not iOS 11?
No, it is iOS 11, but
Huh, I don't have one, so I haven't tested on that, but there is some legacy problems, obviously.
Yeah, I was going to say, I'm going to have to limit myself to the background. It'll not let me access this camera, but it'll let me access this one.
So, okay, so another problem possibly, right? Which camera to choose? So Josh, you're going to have to stand and turn your back towards the marker. Yep, see? There you go, that's all you have to do. And that's a more discreet way to check it. Now I don't know you're looking me up. So that's an easy way for any, to put this kind of verification in anyone's hands, right? Just takes a web developer. I don't need to get an iOS app. I don't need to ask anybody to download all that other stuff I just said. So the hero markers there, this is a really simple one. You can change them. They're easy to generate. And all the browser is doing with the JS is looking for a really thick black border with a lot of white inside and then try to figure out what's inside. And there's a bunch of libraries you can use to generate these. You can create an image and say, hey, here's my image, now turn it into a hero marker, and it spits out a bunch of numeric values separated by commas to represent this image that then JS looks at and evaluates and says, yep, this looks like what I expected. Now I know which image to fetch and overlay. So in that regard, just like the example with the dinosaurs, you can have lots of different markers if your JavaScript is expecting lots of different markers. This also means someone could take this marker and take it wherever they want and recreate it. That's fine. It'll only show whatever picture my website says it's ever going to show. That also makes it harder to fake. So for security reasons, I thought that was a real practical way to display information, more information, or verify information in the real world using augmented reality. So that was ARJS. Their whole spiel, I thought I'd repeat it, is get started in 10 lines or less, because it's a library. So you really can. I mean, this is their default marker. You can just print this out. It works if you, from screen to screen as well, as long as there's not a lot of glare. But that's that library. And I'll put links to all the stuff in the GitHub repo that we always do for these talks. So the other thing I think a lot of people really want is to do what apps do, but in the browser. Not as practical, I guess. This is more of a parody kind of deal to show that the browser can do quite a bit. So the face filters that I was making fun of earlier, those are also possible. So here's Iron Man on my face. This is also working. I actually think, I didn't, sorry. I didn't put the link here. Sorry. Let me see if I can get it real quick. Yeah, we'll just do, in case, actually, you know what, I'll put it up at the last slide. That's fine. And, oh, yeah. And we'll go from there if everybody wants to play different, I got like 4 or 5 of them. There's pretty much just the example they got. But this is doing the same thing. In this instance, JavaScript is evaluating my face, though. So what it's looking for is the same thing, light and dark. Your eyes are much lighter. It's a little darker around there comparatively. There's almost always a dark line here. Even when you have a thick beard, I tried it out, and I haven't shaved just to kind of see if I could fool it at some point, and it seems to find my jaw fair enough. Same thing under your lip, your nostrils. Those are going to be dark enough and different enough to find those places. Now, you start adding points there, and you have a model. And you have a model that a computer is pretty okay at reading. Give it a little bit more. Bridge your nose is usually lighter because of lighting. Darker on both sides. Stuff like that. You give it, the more you give it, the better it is at recognizing a face. Snapchat's really good at this. They have a lot of different points on the face they map. What the library here is basically doing is getting those points for you and then running its version of how those points are supposed to relate. So if I have 2 eyes, which are pretty easy to understand where they are based on the light and the dark, the jawline I can extrapolate to some degree, even if you have a big beard. So it works most of the time, except for when you start removing some of these points. So you turn your head. Now the camera is confused because it doesn't see 2 eyes anymore. It'll only see 1. So yeah, I have an example for that is live. And I'll put it on the last slide here. So not every image works well with this, though. This is me trying to do Raleigh Fingers, one of the old pitchers from the heyday of big mustaches in the major leagues. It found his teeth and around it and thought it was an eyeball because kind of the overall shape and the darkness around it fooled it. So there's definitely tweaking. Like I said, Snapchat's great at this, but this has given me a mustache mouth eye patch, basically. So if you're into that, that's JavaScript too. You can have that. Mustache mouth eye patches. And this is running on my phone. You'll see I have the 158 frames per second. Even on old phones, it's usually pretty high. It's usually 150, sometimes a little bit lower, but I can't remember the oldest phone I tried. It was an Android phone, like I said. Any older iOS, sorry. It's a iOS thing, I guess. So that was a slide I was supposed to remove. So the future of AR and who's going to build it. I saw this animation here, and I was like, yeah, I could see a lot of that happening. This is one instance where probably things like ARKit and whatever are going to save you. Going to save you from building this thing. This chess monstrosity of I don't know what this is. But why not the browser? It's already everywhere. There's no new hardware. There's no new dev environments like Android or iOS or HoloLens. There's nothing more to download. JavaScript's running on just about every browser, unless you specifically turn it off, in which case, sorry, you're such an edge case already. Everybody already works with JavaScript, whether it's on the front side or you're no developer still, you can still use this. And there's no app store to deal with. And that's one of the things that I know some of the web developers I know have, when they get into native development, they're like, why is it so hard to publish an app? And I'm like, Apple hates your logo. You're bad at logo design. And they're like, I don't care about that. I'm like, yeah, but Apple does. So that's a conversation I've had a lot. So I think that's a big appeal to doing these kind of things. No either app store. Not that Google's hard to deal with. They usually they'll accept most anything. But why is native mobile still the thing? And I think part of it is reasons like this. This is during This is during the iOS 11 announcements stuff. This is their page. This is their page at developers or developer.apple for ARKit. You see, it's all polished. It's got example there. It's got that cool logo they made. New framework, easily create stuff. It's super advertised for everything iOS going forward, and they're looking pretty far forward. You see they even have a link up here to iPhone X or 10. I can't remember which one it is. Either way. But Apple's pushing this pretty hard. They want people to build AR stuff in this, and there's a lot of great things in there. They figured out a lot of cool stability stuff. So if you're trying to examine a plane and say that this is a plane here, your AR animation or image won't be very shaky. It'll stay with it a lot better. A lot of cool things like that. That's all great. This was their announcement for the WebRTC. It is the last line in that first bullet point that told developers that they can now use the streaming camera to do stuffs, including mostly AR and things like that. So for their announcement for the browser kind of development aspect of it versus using their kit that gets you in their store, I get it. I get it. Apple prefers native. They prefer their own store. They got way more control over it. If there's monetization, they get involved. It gets more people using their store, meaning more downloaded apps, more proprietary this or that. Google is more open. Surprise. I don't think anybody's surprised by that. But I think that's why, even now, when I talk about AR, usually the conversation goes straight to iOS development. And it's because of marketing like that, I think, when the browser is just fine. And web devs can make the browser experience an AR experience, and that's just a normal thing. It's fairly normal, like I said, like I showed earlier, like on television or in cars or something. It's just not quite normalized yet on handheld devices, and I think it's because of the store aspect of it. And all it takes is some scripting. So, thanks. I think that's about it for me.